Each slit acts like a tiny Helmholtz resonator, reducing mid-range echo while allowing light to pass through. You probably think that killing echo in a bedroom means adding thick carpets or heavy curtains that swallow all your daylight. But there is actually a way to tame sound without sacrificing brightness. It comes from a material that grows faster than any tree and absorbs noise through its own cellular structure. We are talking about vertically sliced bamboo slats. The secret lies not in blocking sound, but in breaking it up. And the best part is that the same surface that controls echo also lets sunlight stream right through. Before we get into the science, let us look at a real-world example that proves this actually works. In 2016, a school in Madrid called Retamar School had a massive problem. Their oratory and assembly hall was a cavernous space with a reverberation time of roughly 7 seconds. That is like speaking inside a giant concrete cave. Every word bounced around and blurred into an unintelligible mess. They needed a solution that would absorb sound, but not make the space feel dark or closed in. So the architects turned to an unlikely material. They chose bamboo slats. The team used thin slats measuring 2,400 by 100 millimeters. Each slat was only 6 millimeters thick and made from 7 veneers of carbonized bamboo. They mounted these slats onto an auxiliary metal structure, leaving a gap of 50 millimeters between each piece. Behind the slats, they installed a black, sound-absorbing material. The combination was simple but deliberate. The air gap and the slats themselves worked together to trap sound waves, not with heavy mass, but with a clever acoustic trick that we will explain in a moment. The result was extraordinary. The reverberation time dropped from 7 seconds down to roughly 2 seconds. That is a reduction of about 70%. Suddenly, the space became clear and comfortable for both speech and music. In fact, the acoustics were good enough for the California Symphony Orchestra to hold rehearsals there. The school's manager, Miguel Ortuño, confirmed that the absorption capacity of the bamboo was the key, and all of this was achieved without lowering the ceiling or making the room feel oppressive. Now here is the physics behind it. Sound waves travel through air until they hit a surface. A hard, flat wall reflects almost all of that energy right back into the room. That is what causes echo. But when you have a surface with narrow gaps and an air cavity behind it, the sound wave enters the gap and gets trapped in the air layer. It then bounces around inside that cavity, losing energy with each reflection. This is called quarter wave absorption. The slats themselves vibrate slightly at certain frequencies, converting sound energy into tiny amounts of heat. The magic number here is the 50 millimeter spacing used in the Madrid project. That gap is not arbitrary. It corresponds to a quarter of the wavelength for certain mid-range frequencies, roughly between 1,250 and 5,000 Hertz. This is the frequency range of human speech and everyday room noise, so the slats are specifically tuned to absorb the sounds that bother us most in a bedroom. Footsteps, conversations, television noise. It does not just reduce echo, it targets the exact frequencies that make a room feel noisy. You might wonder if the bamboo itself is responsible for absorbing sound, and the answer is yes, but not in the way you might think. Research has shown that the sound attenuation coefficient of bamboo paneling averages around 0. 28 np per millimeter when measured using standard impedance tube methods. That is a measure of how much sound energy is lost as it passes through the material. But that is only part of the story. The real performance comes from the combination of the slats, the air gap, and the absorbent backing working together as a system. Let us break down what that attenuation coefficient actually means. The bamboo itself reduces sound energy by about 0. 28 nepers per millimeter of thickness. But that is just the material property. When you install it with an air gap and a sound-absorbing layer behind it, you create a resonant system. The air cavity acts like a spring, and the bamboo slats act like a membrane. Together, they can absorb low frequencies down to around 100 Hz. That is the range of deep bass sounds that often travel through walls from outside. In fact, independent testing on glued laminated bamboo panels has shown sound absorption coefficients ranging from 0, 387, all the way up to 0, 778 at their resonant frequencies. That means these panels can absorb nearly 80% of the sound energy at certain pitches. By adjusting the thickness of the air gap, you can actually tune the system to absorb specific frequency ranges. A deeper cavity absorbs lower frequencies. A shallower cavity targets higher ones. That is why the Madrid project could be customized for speech clarity. Now let us address the obvious question. Does this work in a bedroom, or is it just for big auditoriums? The principle scales down perfectly. You are not trying to control a symphony orchestra. You are trying to soften the echo from your own voice or the hum of a fan. For a small room, you do not need massive panels. You can use a single wall or even a sliding array of slats. Because the gaps let light through, you can treat a full wall without turning your bedroom into a cave. Your plants will keep their sunlight, and you will keep your quiet. There is also an aesthetic advantage that goes beyond acoustics. Bamboo has a natural warmth and grain that synthetic materials simply cannot replicate. The vertical ribbing adds texture and depth to a flat wall. It creates a visual rhythm that feels calm and organic. Many interior designers are now using bamboo slat walls in japandi and biophilic interiors precisely because they combine beauty with function. And because bamboo grows quickly and sustainably, it is a material that feels good to have in your home. But let us get practical for a moment. If you wanted to build this yourself, what would it take? The first step is selecting your slats. You can find pre-made bamboo acoustic panels from several manufacturers. They come in standard sizes like 400 millimeters wide and up to 9 meters long. You would then mount them on a wooden or metal frame, leaving a gap behind for the air cavity. The gap should be at least 25 to 50 millimeters deep, depending on the frequencies you want to target. Then you attach a sound-absorbing felt or mineral wool behind the slats. The spacing between slats is the most important variable. For a bedroom, you can start with the same 50 millimeter gap that worked so well in Madrid, but you can also experiment. A wider gap lets more light through, but absorbs less sound. A narrower gap absorbs more, but blocks more light. You can even make the slats movable, sliding them on a track to adjust the acoustic properties of the room in real time. This is not theoretical. Some high-end commercial installations already use sliding bamboo panels to tune the sound. There is also a subtle but important detail about how the slats are oriented. Bamboo has a grain direction, and sound waves travel differently through the material depending on whether they hit along or against the grain. In the Retamer project, they used carbonized bamboo veneers with specific fiber orientation. The result was a surface that not only absorbs sound, but also diffuses it. Diffusion means the sound waves are scattered in different directions, which reduces the intensity of reflections without making the room feel dead or anechoic. Now let us consider the full sound-absorbing system. The bamboo slats alone are not the only player. The air gap behind them and the absorbent backing both contribute. Manufacturers like Decor Acoustic and Boo Bamboo have tested their panels with different backing materials. Recycled PET felt, for example, can give a noise reduction coefficient ranging from 0, 30 to 0, 85 depending on the installation. That means you can choose a lighter felt for a subtle effect, or a heavier one for maximum absorption. You can even use a perforated top bored behind the slats to boost performance further. One of the biggest misconceptions about acoustic treatment is that you have to cover the entire room. That is simply not true. In fact, A single wall or a section of a wall can make a noticeable difference in a small bedroom. The Retamer project used bamboo slats only on the ceiling and certain wall sections. They did not cover every surface. The principle is the same at home. You do not need a full acoustic overhaul. You just need a strategic placement of slatted panels on the wall behind your bed or along the ceiling perimeter. So here is the final takeaway. Thin vertical bamboo slats, spaced with an air gap and an absorbent backing, are a proven way to reduce room echo without blocking natural light. The Madrid project demonstrated a drop from 7 seconds of reverberation down to 2 seconds. The bamboo itself has an attenuation coefficient of 0.28 np per millimeter. Panels with air cavities can absorb up to 78% of sound at resonant frequencies. And all of this comes from a rapidly renewable grass, not a synthetic foam. The result is a bedroom that feels open, bright, and acoustically serene. That is the quiet luxury of getting the science right. A single wall of bamboo slats, a 50mm gap, and a layer of felt can transform your echo chamber into a quiet sanctuary without losing your daylight. Would you build this for your own bedroom?